All right, welcome to lesson 1.2. My name is Mr. Teal. Miss Christensen and I are working together. I can't speak this morning, apparently. I haven't had enough coffee. Excuse me. Miss Christensen and I are working together. We are doing the videos for each of our classes since we both teach Algebra 2 Honors. So I will be teaching half of the lessons and she will be teaching the other half. So you get to look forward to both of our teaching styles as you move through distance learning this semester. Now, I'm going to be taking you through lesson 1.2. So go ahead and move yourself to 1.2 in your note guide. If you don't have access to your note guide yet, keep in mind they are $20 to be purchased through the banker at Arborview. This is going to make it much easier for you to take notes. So please, please, please purchase that note guide so that we can get all of our notes in one place and keep it really organized. So let's take down some vocabulary first. First of all, you will evaluate an expression if you substitute a number for each variable in the expression. Then simplify using order of operations. You know, PEMDAS, all that fun stuff we learned in elementary school / middle school, whenever you learn that. Then every number or variable or the product of a number and one or more variables is known as a term. So the terms of an expression are essentially each individual part of the expression, and you'll see that a little bit later on. Now, the coefficient, this is a fun word, the coefficient is the numerical factor of a term. So if we're looking at an expression, the coefficient is just going to be the numbers that are outside of the variables attached to the variables. Now, a constant, on the other hand, is a quantity whose value does not change. When terms have the same variables raised to the same power, they are called like terms. Okay, so let's look at the individual parts of an expression. So if we're looking down here where it says, can you write an algebraic expression with two terms and one negative variable coefficient? We're going to try to work all of these into one single expression. So if I write down the expression negative 3x plus 2, this includes all of the separate parts that we talked about before. This number right here, the negative 3, that is going to be your coefficient. And then the plus 2 on the outside, that is the number that is not attached to any variable. That number stays the same always. That is called the constant because it remains constant. It does not change. Okay. There are obviously many other algebraic expressions that you could write that represent the two terms, the one negative variable coefficient, and so on. There are infinitely number of expressions that you can write. So just keep that in mind. This is just one example of them. Now, the negative variable coefficient, that is the negative 3 because there's a negative attached to it. There are two terms. Each individual part of this expression is an individual term. And then we have the constant on the outside. So let's go ahead and convert words to expressions, okay? So one of the cool things we can do with math is we can take words and we can represent them using symbols and numbers. So the difference of 7 and 4. What I want you to look at in this section of problems is the vocab words. You're always looking for your keywords. So for part A, the keyword here is going to be difference. Difference implies that you are using subtraction because we are taking the difference of two numbers. So if we're taking the difference of 7 and 4, that's simply going to be represented as 7 minus 4. Now we're going to stop there. We're not going to actually solve 7 minus 4 because the directions just say to write the algebraic expression. For part B, we have the product of 3 and x. The keyword here is product. Product implies that we are multiplying two things together. So we're going to write this as 3 times x. Part C, the number y increased by 2. The keyword here is increased by. That implies that we are adding two terms together. So we're going to say y plus 2. Moving to part D, the quotient of 48 and 3. Quotient is a vocabulary word that means division. So we're going to be taking 48 divided by 3. All right, so now when we move down to part E, this is where it starts to get a little bit more complicated. So I want you to just write off to the side. Be careful here because the order of the terms is going to matter. Okay, so we have to be very careful to see the order in which the terms appear. So that's going to help tell us where we have to put each of our numbers and terms into the expression. So for part E, we said the number n is doubled, then decreased by 1. So we have a couple different parts to this expression here. The first part, the number n is doubled. That means we are taking n and we are multiplying it by 2. We are doubling it. So the first thing I'm going to say is 2n because I'm doubling n. Then for part 2, I am decreasing by 1. Decreasing means we are doing subtraction, okay? So that's going to be 2n minus 1. Once again, be careful because order matters once we get to multi-step expressions like this. Moving on to part F. Now this one I want you to be very careful of, okay? We have to pay attention to the vocabulary. 5 less than W. Less than is a word that tells us exactly what the order is going to be. So I want you to think about real numbers here. So we are going to say 5 less than W. What if I said 5 less than, I don't know, 8? What is 5 less than 8? Well, we know that 3 is the number that is 5 less than 8. So we're not taking 3 minus 8, we're taking 8 minus 3. So the order here is going to be a little bit backwards. So if we're looking at 5 less than W, that's going to be W minus 5. We are taking W and subtracting it by 5. So this one is going to be a little funky because we have to change the order. So just be careful there. All right, moving on to part G. We have 2 times the sum of A and B. Now, a couple different parts to this one. Once again, we have to pay attention to the order here. 2 times means we are doubling something, but we're doubling a sum. So we're going to have to make sure that we include parentheses so that we are really adequately doubling the things that we want to double. So if we're doubling the sum of A and B, that means we're going to have to put the sum of A and B in parentheses because we're not just doubling A, we're not just doubling B, but we're doubling the sum of A and B. So I'm going to put 2 out front, and I'm multiplying that by the sum of A and B. So A plus B. Oh, excuse my little coffee stain here. I'm telling you, if I don't have coffee, I'm the most grumpy person ever. So if you have Mr. Teal on your schedule, you better hope that I have Starbucks in my hand every single day when you get back here in person. Otherwise, it's going to be an ugly day for everybody. All right. Moving on from that, moving on to part H, the inverse of a number increased by its absolute value. Oh my goodness, there's so much going on right here. We're going to have to be careful. So first word that I see is inverse. Now what inverse implies is that we are using the negative value of that quantity. Inverse means negative values. So we're looking at the inverse, so the opposite of a number increased by its absolute value. So since I am looking here at a couple of different things, first of all, the inverse of a number is going to be inverse of a variable, let's just say n, okay? Now we're increasing this. Increasing means we are adding something to it. So if we have the inverse of a number and we're increasing it by its absolute value, we are adding the absolute value of that number. Okay, so let's go over the parts again. The inverse of a number, so the inverse of n, increased by, so plus, its absolute value, so the absolute value of n. All right, be very careful with these examples, paying attention to the order. Moving down to part I, the absolute value of the difference of 2 numbers. Absolute value, that means we're going to have these 2 bars, and we're taking the absolute value of the difference of 2 numbers. Now, since I'm not specifically saying which numbers, all I'm going to do is I'm going to assign them variables. So you could assign them the variables x and y. You could assign them the variables a and b. It doesn't matter. But if we're not specifically talking about 2 specific variables, assign your own variables to them. We're just talking about any 2 random numbers. So the absolute value of the difference of 2 numbers, I'm going to say absolute value of x minus y. All right, moving on to part J, the inverse of the absolute value of twice some number. Once again, some number means you're going to have to assign a variable here. Doesn't matter which variable you assign. I'm going to go ahead and assign x just because I like x's. So the inverse, once again, that's going to be a negative of the absolute value, put the absolute value symbol, of twice some number. Twice some number means we are multiplying 2 times that number. So it's going to be 2x inside of the absolute value. Now, if you put the absolute value of 2a the absolute value of 2z, doesn't matter as long as you assign a variable to it. All right, moving on to the next page, we are going to look at example 2. So now we're going to do the reverse of what we did before, right? A verbal expression for each algebraic expression. If we are looking at 5n minus 1, we want to try to figure out how to express that by words. So one of the ways you could say this, and there's a couple of different ways you could, but I'm going to go ahead and write down the way I would say this. Since I have 5n minus 1, I know I'm going to have to talk about 5 times a number, but how am I going to make sure that I'm specifying that I have 5n minus 1 and not 5 times n minus 1? That's where this starts to get tricky. You have to be very careful with your wording. So the way I would say this is I would say 1 less than 5 times a number. And what this does, this completely eliminates the possibility of getting confused with 5 times n minus 1, because this is not what we are looking at here. So this is something that I want you to be careful of not to represent, because if we said 5 times a number minus 1, that would imply that we're using this expression right here, but we're not. We're saying 5n minus 1. Those are 2 separate terms. So I would represent this saying 1 less than 5 times a number. All right, moving on to part B. So similarly, we have 2n plus 3. We have to be careful with our wording so that we're not mistaking this for something that would be written in parentheses. So what we're going to say is 3 more than double a number. You could also say 2 times the number. That would be fine. All right, so 3 more than double a number would be the way to represent this. All right, so moving on to part C. Now we're going to talk about what we would do here. So we have x plus 7 over 2. Now there's a couple of different ways we could represent this. I am going to use the fact that x plus 7 divided by 2 means we are taking half of x plus 7. So what I would say is we are taking half of, now remember, we want to be very specific. We don't want to say x plus 7. We don't want to say divided by 2 or anything like that. We want to say the sum of x and 7. So I'm going to say half of the sum. Now, since this x is a variable, I'm going to say half of the sum of a number and 7. All right, that's how I would represent that statement. Okay, moving on to part D. So we have 3 times the quantity x plus 8. Now, we want to make sure we're talking about and accounting for that parenthesis set. So what I'm going to say here is I'm taking 3 times, and inside the parentheses, we have a sum. So I'm tripling that sum. So I'm going to say 3 times the sum of a number and 8. 3 times the sum of a number and 8. All right, moving down to part E, we have -6 squared. Now, remember, we always represent those negatives either by saying opposite or inverse, okay? We don't want to say negative. We want to try to refrain from using that term. Let's be more specific by saying opposite or inverse. So what I'm going to say here, this is the opposite of 6 squared. Now, it's okay to say 6 squared, all right? Oh, the lights are turning off. I guess it's time to go home. Lights are off. Just kidding. Hold on. Oh, so sorry you had to see this. Oh, my goodness. I am telling you, those lights turn off at least 15 times a day. It's really annoying. So now we're going to look at F. Now, notice how F is the same thing as E. The difference is, though, we have the -6 inside parentheses, so we're going to have to be very careful about how we say this. This is -6 inside a quantity squared, okay? So what we're going to say in this case, because the -6 is inside the quantity, we're squaring it, we can be a little bit more lenient with saying negative. So I'm going to call this -6 squared, all right? Since the negative is inside the parentheses, you are allowed to say -6 squared because that is the number that we are squaring, and we're not necessarily taking the inverse of it. All right, let's move down to example number 3. So model each situation with an expression. You had $150, but you are spending $2 each day. And we have a couple things we're looking at here. We are looking at a constant, and we are also looking at a value that changes. $150, we have that in our account no matter how much we spend, okay? $150 is what our account starts with. We are spending $2 per day. So we are going to be subtracting $2. That's the value that is going to change depending on how many days we're looking at here. So something I want you to be careful about here, I want you to write off to the side, attach the variable to the value that something is changing by. Okay, so if we are subtracting $2 from our bank account each day, that is what our number is changing by, $2 each day. So we want to attach the variable to the number that we are changing by each day. The constant is going to be on the outside untouched, okay? Because that's the number that we have to look at to see how much we are subtracting from that number and what our final value in our bank account is going to be. So if you had $150, but you're spending $2 each day, I'm going to say we start with 150, but we are subtracting off $2 per day. So I have to attach a variable to that 2 because we are changing by 2 per day. And depending how many days we're looking at, that's going to change how much money we have in our account. So that's going to be 150 minus 2d. So we are taking expressions by words and modeling them with symbols and numbers. Moving down to part B, you start with $15 and you save $8 each week. So the starting value is your constant. We're going to start with 15, and we are saving $8 each week, which means our bank account is going up by $8 each week. So we're going to say plus 8W. Depending on how many weeks we're looking at, that's going to tell us how much money we have saved and how much money we're putting in our bank account. You receive your regular salary plus a 5% bonus of your regular pay. So your regular salary is your constant. We don't know what your regular salary is, so we're just going to call that S here. Your regular salary, you are always receiving, but in addition to that, you're going to receive 5% of your regular pay as a bonus. So now we're going to add on 5%. Remember, we always represent percentages by moving the decimal 2 times to the left. So 5% is going to be 0.05 of your salary. So we have your salary plus 5% of your salary. Part D, your cell phone plan allows 750 text messages and you text 25 messages every day. I text way more than 25 messages a day, so this is making me feel really bad about myself. Now, you start with 750. That is your constant, okay? That does not change. Each month, you are allowed 750 text messages. You text 25 messages every day. So that is going to be your variable. We are subtracting 25 per day. Remember, the value that something is changing by, that is what you attach the variable to, because that's going to allow us to see how many texts we have left over after a certain amount of days. All right, let's move down to example 4. Example 4, we are going to evaluate each expression for the given values of the variables. So if we have b squared minus 4ac, oh, that looks familiar, does it not? What we want to do is we want to evaluate this expression when a equals -2, b equals 5, and c equals 3. So all we are going to do is plug them in. That's literally it, okay? So I'm going to substitute all of these variables for the values I've been given. So if I have b squared, I'm going to, instead of saying b squared, I'm going to substitute in b. So I'm going to actually make this a different color, try to be cute with my math teaching here. So b equals 5. So what I'm going to do is I'm going to plug in 5 wherever I see b, and I'm squaring it. Then I'm subtracting 4 times a times c. Now, since I'm plugging in a, I know that a is -2. So instead of a, I'm going to say -2. And then I'm still multiplying by c at the end. And I'm going to make c green here. C is 3, so I'm going to plug in 3 where I see that c. So instead of b squared minus 4ac, I now have 5 squared minus 4 times negative 2 times 3. Let's go ahead and clean this up a little bit. So 5 squared, I know that is 25. I am subtracting, I'm actually going to change this to addition because I have negative 4 times negative 2. Negative 4 times negative 2 is going to be plus 8 times 3. Then I have 25 plus 8 times 3 is 24. 25 plus 24 is going to give me an answer of 49. All right, so all we have to do is plug them in, make them nice and pretty. Part B, x minus x squared times y. We are going to substitute x equals 3 and y equals negative 4. So I'm going to plug those values into my expression. So wherever I see x, I'm going to plug in 3. So I have 3 minus x squared, that's going to be 3 squared, times y, which is negative 4. Now let's clean this up a little bit. I have 3 minus 3 squared is 9 times negative 4. All right. Now I'm going to do multiplication using order of operations. So I have negative 9 times negative 4. That's going to be positive 36. So I have 3 plus 36. 3 plus 36 is equal to 39. Nice and simple. Moving on to part C. 2 times x squared minus y squared divided by 3. I'm going to plug in x equals 6 and y equals negative 3. I have 2 times x squared, so that's going to be 2 times 6 squared, minus y squared, so negative 3 squared, divided by 3. Now we have to be careful here because obviously we have parentheses within parentheses. What might be a little bit neater, if you want to change these parentheses into brackets, just so you can keep everything straight, that might be a good idea. So I'm going to do what's inside of the parentheses first. 6 squared is 36, so I'm going to say 2 times 36 minus negative 3 squared is 9, divided by 3. Okay. After I do that, oh, stupid lights. 36 minus 9, that is going to give me 27. So I have 2 times 27 divided by 3. Now, since 27 and 3, we can pull out a 3 from 27. I can divide those two. I'm just going to do that now to make my life a little bit easier. So if I pull a 3 out of 27, 27 divided by 3 is just going to give me 9. So then I just have nothing in the denominator, just 1. And in the numerator, I have 2 times 9. So my answer is going to be 2 times 9, which is equal to 18. So my final answer here is 18. All right, let's go ahead and move on to the next page. So for example number 5, we are going to simplify each expression if possible. If not possible, we're going to write them in simplest form. So this is where combining like terms comes into play. A couple of things you need to remember for combining like terms. Only combine terms if they have the same variable and if that variable has the same degree. So we're looking for same variable and same degree. If they do not have the same variable and they do not have the same degree, you cannot combine them. It is not possible. Okay, so for part A, 8m plus 7 plus 11m minus 13. We're going to combine the two m values together because those are like terms. Same variable, same degree. They both have a degree of 1. And now I'm also going to combine 7 and negative 13 because I know how to add 7 and negative 13. So let's go ahead and do this together. So 8m plus 11m. 8 plus 11 gives us 19. So I'm going to have 19m. And then 7 minus 13. Well, I know 7 minus 13, I'm going to have left over negative 6. So my answer is going to be 19m minus 6. Again, only combining those like terms if they have the same variable and the same degree. Obviously, we can combine the constants because they don't have any variables, and we already know how to add two numbers. All right, part B, 12y squared plus 5x squared. Oof, can I do anything with this one? 12y squared and 5x squared, these two terms do not have same variable, and they do not have the same degree. The variables themselves do have the same degree, but you can't combine them as they don't meet condition number 1. Condition number 1 was failed, okay? So what I'm going to say, since I can't combine these, I'm going to say that this is in simplest form. All right, moving on to part C, I have negative 16m plus 7 times quantity 3m minus 4. Now, my first instinct whenever I see a whole number multiplied by a parenthesis set, what I'm going to want to do is I'm going to want to distribute that number into the parentheses. So I have negative 16m plus 7 times 3m is 21m. 7 times negative 4 is minus 28. Now I'm going to combine like terms. I have negative 16m and positive 21m. So what I'm doing here is I'm taking 21 minus 16, which is equal to 5. So I'm going to have 5m minus 28. And since I can't combine anything else, that is going to be my final answer, 5m minus 28. All right, last but not least, looking at D, I have 5 times quantity 4x squared minus 2 minus 16 plus 8x squared. I'm going to take this number out here, distribute it into the parentheses. That's the first thing I do. 5 times 4x squared is 20x squared. 5 times negative 2 is negative 10 minus 16 plus 8x squared. Okay, so now I have some like terms. So what I want to do here is I want to combine the like terms. First, I'm going to determine which ones are like. So 20x squared and 8x squared, those are two terms that both have x squared attached to it. Same degree, same variable, so we're good to go. And I also have negative 10 and negative 16. Those are like terms, I can combine them. So now I'm going to say 20x squared plus 8x squared gives me 28x squared. Then negative 10 minus 16 gives me negative 26. So my final answer is going to be 28x squared minus 26. All right, moving down to example number 6. I have name the terms, coefficients, and constants for each expression. So we're going to go back to the vocabulary words that we introduced in the beginning of the lesson today. Now, we always want to make sure we know what these vocab words mean. The terms are going to be each individual part of the expression. So the terms are literally going to be 2x squared, negative 3x, and positive 5. All of the terms that are in the expression, no matter if they're constants, no matter if they're variables, no matter if they are the coefficients, we are going to include every individual part of the expression underneath the term category. Now, coefficients, these are going to be the numbers in front of variables. So all of the numbers in front of the variables, that's what's going to go under coefficients. So I have 2 and I have negative 3. Those are the two numbers that have variables attached to them. So my coefficients are going to be 2 and negative 3. My constants, those are going to be all of the numbers that don't have variables. So I'm going to say numbers without variables. Those are my constants. Okay? So my constant here is just going to be 5 because that's the only number that does not have a variable. Let's go through part B very quickly now that we know what terms, coefficients, and constants are. So my terms for this expression, each individual part of the expression, I have negative 4yx, I have positive 8x, and I have negative 3. Those are my three terms. My coefficients, all of the numbers attached to the variables. I have negative 4 and positive 8. My constant, the number that is not attached to any variables, usually it's at the end, we're going to have negative 3. All right. So let's move on down to example number 7. We are now going to write an expression to model an actual like word problem. So we're going to take all of these sentences, all of these words, and make them into an expression. So we have the freshman class will sell pinwheels for peace as a class fundraiser. What is the total income after buying materials from the office supply company for a flat fee of $86, and they sell P pinwheels for $2 each? Okay. So I want to think about this very intuitively. This school fundraiser, the freshman class, purchased all of the supplies for this fundraiser for a flat fee of $86. So they are going to have to pay $86 to the company in order to put on the event. Now, they have to see how much should we sell in order to make money off of this, and we want to write an expression that allows people to do that. So We are selling these for $2 each. I'm going to say that P is pinwheels. I always want to assign my variables. Okay, it's very important to assign the variables so we know what you're talking about. But in order to represent this situation, all of the income off of the $2 per pinwheel is going to be represented by 2P. I get $2 per pinwheel, so I can just plug in however many pinwheels I sold in for P. However, the one cost that I have to take care of is I have to subtract off the 86. And once I get this, you guys, this expression is going to tell me how much money I made. So let's say you made let's say you sold 100 pinwheels. So if we sold 100 pinwheels, we're going to have 2 times 100 minus 86. So that's going to be equal to 200 minus 86. 200 minus 86, that is going to be 114. So what that means is I have made $114 off of this fundraiser, okay? So this is a very handy expression that we have created that allows us to see how much money we made after the fundraiser is done, depending on how many pinwheels we sold, okay? All right, let's move on to the very last page. We're just going to go over some properties for simplifying algebraic expressions. So I want to talk about specific math definitions to you. So let's go through these very quickly. So some things we talked about today: let A, B, and C represent real numbers. The definition of subtraction, that is going to be A minus B is equal to, and here's how we actually mathematically represent subtraction, A plus negative B. Okay, that is the definition of subtraction. Definition of division, A divided by B is equal to A over B. We can represent that as a fraction, which is also equal to, we can pull out this A and say A times 1 over B. However, B cannot be equal to 0. Here's the formal definition of division. A divided by B is also represented as the fraction A over B. We can pull out A and just multiply A times the fraction 1 over B. B cannot be equal to 0. All right, distributive property for subtraction. If I have something like A times B minus C, I know that I can distribute this A to both terms inside the parentheses. So that's going to be represented by A times B minus A times C. Multiplication by 0. If I have 0 times A, that can also be written as A times 0, which can also be written as just 0. Multiplication by negative 1. If I have negative 1 times a number A, that's also equal to A times negative 1, which can be represented as negative A. Again, these are all properties that you are probably already familiar with, but this just kind of puts it into more mathematical terms. Opposite of a sum. If we're looking at opposite of a sum, we have negative A plus B, so we're taking the opposite of a sum of two numbers. And what we can do here is we can distribute this negative to both terms inside the parentheses. So this can be turned into negative A minus B, but also remember how we represented that subtraction up here. Instead of saying one number minus another number, we technically mathematically represent that as negative A plus negative B. Opposite of a difference, if we have negative A minus B, we're taking the opposite of the difference of two numbers. What we can do here is we can distribute this negative into the parentheses. I have negative A, and then negative times negative B, negative 1 times the negative is going to be a positive plus B. Opposite of a product, if I have negative A times B, I can rewrite that as negative AB, or negative A times B, which can also be written as A times negative B. That negative can be attached to any of the terms. As long as the negative is there, you are going to be looking at the opposite of a product. Opposite of an opposite, if I have a negative number, so opposite of a negative number, that is really essentially equal to a negative times a negative equals a positive. So we just have equals A. All right, you guys, that concludes 1.2. Go ahead and complete your homework assignment corresponding to 1.2. If you have any questions, please let me know. And we will be back here for the next lesson. Thank you.